Good afternoon. Welcome back to Battlesnake Official on twitch.tv. Today we are joined again by the AWS Deep Learning team, Xavier, Jonathan, and Anna. Super excited for round 2 of the SageMaker Machine Learning workshop. So pretty much today they're going to be running through the whole workshop again. They're here to answer any questions. Feel free to ask anything in the Twitch chat, or you can also run over to the Slack, the Battlesnake Slack channel, and there's a few extra AWS and SageMaker team members there hanging out who can answer your questions as well. All right, thanks everybody. I'm going to pass it off to the wonderful team at AWS. Hope you enjoy their workshop.
Welcome to this Battlesnake with Amazon SageMaker workshop. My name is Xavier Raffin. I'm a solutions architect at AWS Vancouver, and I will be presenting this session with 2 of my colleagues. So Jonathan, if you want to introduce yourself.
Hi, I'm Jonathan. I'm an applied scientist based in Vancouver. Anna?
Hi, my name is Anna. I'm an applied scientist based in Seattle.
Okay, so what we'll do today, so it's a live workshop. We will first explain you a little bit about how it works. It's all based on an open source project we'll talk about. So we will start with this explanation and then doing a demo live. So what is recommended is you following what I am doing. So I try to do everything step by step. And the only requirements to follow this workshop with me is to have an AWS account. So first, in order to start the workshop, there is a URL. So the first on top of this page, tinyurl.com/battlesnake-AWS. So it's a short link to the page with all the information regarding the current workshop. And so here you will find direct link to instruction and where to find help during this workshop. So we will try to collect questions from this your Twitch comment and maybe to answer the questions at the end of the Twitch channel live. But another way for you to get help for the workshop is to go on the official Battlesnake Slack channel and to go on the channel Snake Dev Machine Learning on Slack. So several of my colleagues are already connected to this channel. So if you run into any issues, you have questions regarding the steps of the workshop, you can go here and ask any of my AWS colleagues that are online. And if you are not already registered to the Battlesnake Slack channel, there is a link in the instruction to do so. So again, the most important link for the workshop is the first one here, tinyurl/battlesnake-AWS. Go here and you should see a page like that. So this page shows where are the instructions for the workshop, the source code, some name of people that can help you on Slack. And again, 2 ways to obtain help during the workshop on the Slack channels. And even after the workshop, if now not finished, we are still part of this Battlesnake community and we can help you on Slack. Okay. So now about Amazon SageMaker, AWS, and Battlesnake. So AWS stands for Amazon Web Services, is one of the sponsors of the Battlesnake events. We were sponsor since last year, and we provide infrastructure solutions for any companies that have needs for IT infrastructure. And among the services we offer to our customers, there is one named Amazon SageMaker, which is dedicated to AI and machine learning. And it's a service that helps to automate a lot of tasks that data scientists and computer science developer in ML will do frequently, like training ML models, deploying ML models for doing inference, doing fine tuning on these models to improve performances, sharing models between a team, and action of these types. So we built this on GitHub, a snake that is a demonstrator about how to build a snake for Battlesnake competition. using the SageMaker framework. And this will be the focus of the workshop today. Inside this workshop, there is 3 main modules. So the base one at the bottom here, it's a one-click deployment module. So from the page in GitHub, and from the GitHub project, there is some deploy button. I will show you that in a minute. And this will deploy in the AWS account you have. This will deploy all the environment into SageMaker. This is the first one you need. And once you do this one, you have a Battlesnake ready to participate to games. It's not designed to win the competition. You'll have to work to make it better, but it will be already working. And then once it's deployed, there is 2 modules. The first one here on the left is a reinforcement learning module, which will be the first one we will try, where we will train the agents. And here what you can do is change the way we decided how to train the snake to make it better and to see if you can improve your score in the competition. And the second one, Heuristics Module, on the right, is about to add behavior on top of the AI decision to override that and to try to make it better. Sometimes it's easier to do a heuristics you build yourself instead of relying only on the AI. And just before jumping in, so this will be the infrastructure that the one-click deploy solution will spin up into your AWS accounts. So API gateway, Lambda function, and you can see 3 boxes. So these are 3 instances within SageMaker. So the first one here, SageMaker endpoint instance, is where your model will run. It's where your snake is live, basically. And it has 2 things. It runs the AI model for doing prediction about what should be the next move, AI heuristics that you can override. And it deploys also a training environment under the form of a SageMaker notebook instance with 2 notebooks, one to create and train the model, and the second one for the heuristics. We will do both together. And the one that trains the model can also spin up a training instance to run the training itself. So because this infrastructure stack deployment takes a few minutes, around maybe 10 minutes, what we will do now, and I suggest all of you do the same, is we'll be deploying this stack, click deploy, and validate the deployment, and then we will go back to the presentation because we don't want to wait 10 minutes after the presentation. So go back on the main page here. Make sure in another tab that you are logged into your AWS account. Okay, so make sure that in your browser you are logged inside your AWS and management console. Okay, so if you're logged in on the instruction page, you can use this link, direct link to the deployment page. So this will go directly to the phase where we deploy everything. So if you go, so I click here just to show you what it looks like. And here you see a table with multiple links to deploy the environments. I recommend you to use the Oregon region, US West 2, because the Battlesnake engine itself from the competition is running on US West 2. So you will have the smallest latency and the best performance using that link. Okay. So from that page, click on deploy link. Just before doing that, I just show you also the base of the project. So if you start from the root of the project, instead of starting from the event page, so this is the root of the project. There is explanation about all the steps, but the main 3 steps are these ones. And step 1, deploy a snake, is the step we are interested in right now. So you can also click here, deploy a snake. You go a little bit down, and you find the same table. Okay, you are at the same place. Okay, so once you're good with that, click on deploy here, and that will redirect your browser inside your AWS account console in a page that will be already ready to instantiate all the infrastructure we need. So you go down a little bit. About the parameters, you can left the name the same. our project contains two RL methods. So we will enter a little bit into the detail of that. So today we will use the RLlib method, which is using TensorFlow, but there is also another method. So today left RLlib. Here you can choose the instance type. So think the size and type of server you want to use to run your training and inference. So here your choice depends about how old is your AWS account. If you just created the AWS account today or in the last 2 to 3 days, you can left everything defaults. Okay, MLT2 medium, you left everything defaults. If your account is older than that, you should probably choose something like ML-M5 X-Large, since the ML-M5 X-Large is part of the free tier, of the AWS free tier, so it's totally free of charge if you run that for less than 125 hours, and for the workshop we will do a lot less than that. If your account is new, again, use MLT2 medium because the second will fail. So yes, you will be charged, but if you just run it during the workshop and you stop using it at the end of the workshop, then you will be charged a few cents. So not zero, but few cents. So depending on the age of your account, use one or the other. So if it's new account, you left default, T2 medium. If it's an older account, you can use ML-M5 X-Large. So myself, I will use ML-M5 X-Large. And you can do twice the same choice on the two types. Then you have some customization options. You can change the color of your snake, the head, the tail. You can left default. It doesn't really matter right now. Okay, and then you go down here and you acknowledge all these permissions. So these permissions means that yes, I agree that this stack, this template is allowed to create resources on my behalf on my AWS account. And then you click Create Stack. Okay, so you will land on a page like this, which is inside the CloudFormation service, where you should see Create in Progress label over here. That means the creation of the stack is in progress. Okay, so this will remain for about 10 minutes. So that's why we can now switch back to the presentation. So just make sure everybody has that. And once you have your Create in Progress, then you can hold on and you're ready. Okay. Okay, coming back to the presentation. So during the next 10 minutes, it will deploy that. So with that, I will let my colleague Jonathan for continuing the presentation to explain you how works this open source solution.
Hello, everybody. I'm Jonathan, and you can find me on the Snake Dev Machine Learning channel on Slack if you have any questions. So this part of the presentation, I'll be discussing the reinforcement learning module. So let me just talk about the reinforcement learning module and briefly how reinforcement learning works. So as you can see on the slide, in reinforcement learning, you have an agent that interacts with the environment. Could you go to the next slide? So specifically, the agent provides an action, which you can see on the top, which changes the state of the environment, which you can see in the middle. And then the environment provides a reward for the action that each agent took. And the aim of the agent is to maximize the accumulated future rewards. So next slide, please. So let me give you an example. So for example, you have a self-driving car, and the car is the agent. So the agent, for example, it can accelerate, decelerate, turn left, turn right, etc. And the environment could be the road. The agent will view the environment maybe in the form of images. And the reward, as you can see on the bottom, is the number of kilometers that the car has driven. So for example, if the car sees that the road is turning towards the right, then to maximize the number of kms driven, the agent will also turn right. So let's just say the environment shows a stop sign. Next slide, please. You might think that the agent should just ignore it and keep going forward because the reward is to maximize the number of KMs driven. But in reinforcement learning, the aim is actually to maximize all future rewards. And by stopping in front of the stop sign, it will increase future rewards rather than the immediate rewards. Next slide, please. So in terms of Battlesnakes, the actions are quite simple. It would be whichever direction your snake goes, which is up, down, left, or right. The states will be a representation of the positions of the snakes, the food, and the position of other snakes. And so for the reward is a bit more complicated, so I will go into that a bit later. But in Battlesnakes, the interesting part is that it's not just one snake, it's actually multiple snakes. So next slide. So this is called a multi-agent reinforcement learning problem, where there are multiple agents, each providing their own actions, and you also get a reward per snake. So an example of a multi-agent reinforcement learning problem includes StarCraft or AlphaStar, which controls many units separately. So essentially, the configuration of the problems is the same, as you can see on the plot here. And I'll explain each one of these components in detail. So next slide, please. So I simplified the previous diagram a bit, and it's shown on the top right of the screen right now. So let me first explain the environment. So we modeled the rules of the gyms, where, for example, how the snake moves, eats, grows, and dies in an OpenAI gym format. This environment takes the actions and moves the snakes accordingly. And afterwards, the rewards and the states are emitted out. So next slide, please. So let me explain how we represented the state. So let's just say we have a very small board, as you can see in the middle here. We have 3 snakes, an orange one, a green one, and a blue one, and there's a food in the bottom middle. So a method of representing this is, next slide, is to use a image-like representation. So, so for example, we have 3 snakes, so then we need 3 agents in the multi-agent environment. And each agent is fed with a specific image. So for example, the agent that is representing the orange snake will be fed an image as shown here. So similar to an RGB image with 3 channels, the first channel will be the position of the food. The second channel will be providing information of the what we call the self snake, which is the snake that the agent is representing. And the third channel will provide information of where all the other snakes are. You can also see that in the middle slide, the self snake, the head is actually represented as a 5, whereas the body is represented by a 1. And we did that because we thought that the head was more important. So then we had to provide more signal to the agent. So next slide, please. So let's just say for the agent representing the green snake, the snake position is shown in the green snake is shown in the middle channel, and the other snakes are shown in the third channel. And next slide. Similar for the final permutation, where the blue snake is presented in the middle channel. So let me discuss a bit about the reward right now. Next slide, please. So as you can see on the slides here, the gym currently supports a large variety of rewards. So let's just say if you want a very defensive snake, you would just maybe try to go for the surviving another turn reward or just winning the game. Another method is that, okay, so let's just say you want a very aggressive snake. Maybe you will force all the snakes to just, the only reward that you care about is eating another snake or forcing another snake to hit your body. So you can really customize how you want your snake to act based on the rewards that are provided here. So let me talk about the last part, which is the agent. Next slide, please. So the agent takes the states and figures out which is the best direction to move in. And note that the reward here, as you can see in the diagram on the top right, is only used in the learning process. So how do we figure out which direction to take? So next slide, please. So we use a neural network to learn this behavior. The input is an image, and the output is a vector of size 4, which represents up, down, left, or right, each one of the directions that the snake could take. So how do you train this neural network? And my teammate Anna will describe SageMaker on how to train this neural network. Thank you. Next slide.
Thanks, Jonathan, for the introduction. My name is Anna, and I will be introducing how to train your neural network, the agent model policy on SageMaker. So assuming that you already have the environment implemented using OpenAI Gym interface, and now you want to train the policy which involves a neural network on SageMaker. In the previous version of the Battlesnake starter kit, we provided a training script that uses a MXNet to update the model, and the algorithm is DQN, Deep Q Learning. Can we move to the next slide? So today we provide an update of the Battlesnake starter kit in which we integrate the current solution with SageMaker RL. So I will be introducing SageMaker RL really briefly. SageMaker RL is built on top of SageMaker. It integrates different RL toolkits, for example, RL Coach, developed by Intel, and RL Ray, developed by UC Berkeley. And also it is deep learning frameworks agnostic, meaning that you can train your model using either MXNet or TensorFlow. And a strong thing about SageMaker RL is that instead of training your algorithm on single instance and with single node, now you can spin up and scale your RL experiments to train on multiple instances using distributed RL, so that your snake can achieve a good policy in a short time. And of course, you can use either local simulation or remote, and you can use CPU or GPU depending on how heavy the neural network training is. Can you go to the next slide? This is a brief decomposition of SageMaker reinforcement learning. And we can see a green box there, which says RL Ray RL Lib. And this is the RL library that we use to train our snakes. It includes the library itself. It supports a set of state-of-art RL algorithms. So you can start with DQN, that's the classical deep reinforcement learning algorithm. And you can also try out other algorithms and see how your snake performs. In terms of the framework, now we demonstrate how to use TensorFlow to kickstart the training. Can we go to the next slide? In terms of the reinforcement learning environments, as we can see here, SageMaker RL supports different types of simulation environments, including AWS native environments, open source environment, and most importantly here, for our Battlesnake problem, we coded our environment using OpenAI Gym interface, and that falls into the green box, the custom environment, bring your own environment. Next slide, please. Yeah. Here is the GitHub repo of a set of public examples using SageMaker RL. So Battlesnake falls in the region of game, but you can use RL techniques to solve other domains of problems as well. For example, bandit problem for recommendation system, and for RL for robotics, for HVAC energy optimization, and for auto scaling. So if you're interested in them, feel free to check out the GitHub repo. Can we go to the next slide? Right. So assuming that we have already trained our snake policy and the agent using SageMaker RL, now we're coming to a stage where we decide whether we want to tune the policy. When we talk about tuning, we have different options to go forward. For example, how to decide the better neural network parameters, the structure, how do we better configure the learning rates? And of course, when we decide the simulated environments, how do we put appropriate configurations in terms of the state representation and reward shaping, etc. Next slide, please. This is an example of tuning. For example, we have the state representation and we have this training phase where the agent interacts with the environment. The agent sends out the action and the environment sends back the next state and rewards. We may be interested in looking at how different maps would affect the policy of the snake. Then we can decide whether we want to train a snake with a border, with the map border, or without the map border. Next slide, please. Next slide, please. Right. This is when we're already satisfied with the model trained on SageMaker. Now we can decide whether we want to deploy the model onto cloud. And from here, my colleague Jonathan will introduce how to deploy the snake.
Hi. So I'll discuss the Heuristics module and how to deploy the snake. So firstly, let me talk about the Heuristics module. Next slide, please. So in theory, in reinforcement learning, you should get a perfect snake. But in practice, time constraints usually makes it very difficult to train a snake for every situation possible, especially when you're playing on the global ladder and there are very strange strategies that you can see there. So I believe that it'll be useful to add some human intuition into the snake that will override the commands of the AI. So the heuristic module works like this. So next slide, please. So let's just say your AI tells your snake to go up. And this command will be fed into the module, as you can see in green. And next slide, please. Along with the snakes, the health of all the snakes, and the number of turns that has gone by, you would your code could decide which direction to take. So essentially, what you can do is to override whatever command that your AI tells you to do. So as you can see here, originally the AI said, okay, we should go up, but then your code actually, in fact, says that we should go to the right. So next slide, please. So also the heuristics module provides what we call a simulations simulator component. So for example, you want your snakes to be in the exact configuration as you can see on the left of the screen, where you kind of have a big orange snake wrapping around your green snake. You can define the gym to have the exact same configuration and to see how your snake behaves. You can see if the AI actually manages to deal with this, or if you need to write a heuristics to cover this. So after this, when your heuristic module is complete, you can simply click the deploy button that will put your snake onto the cloud. And my colleague Xavier will describe how to do it in a demo. Next slide, please.
Okay. So, am I back? Okay, I assume I'm back. So now you have a pretty good understanding about what we will be running. You can go to the main page event, or you can go directly to the GitHub project and to follow the workshop steps. But I will show you all of the steps you need to follow one by one. So switch in your browser. And if you come back to the environment we deployed a few minutes ago, and you refresh here, and here you can see, if you refresh the state, you can see now the status changes to create complete. So that means the environment is deployed. And among the tabs that are here, you should go to outputs. And inside outputs, there is a very first thing named check snake status. This one is to use to make sure that the snake is working properly. So click on that link. Yeah, I open it in a new tab. And let's see, okay. Here the snake is ready. So that means everything worked. If you have something different, you may have a message information. One of the most common errors here is you have a new account and you launch MLM5X large and you are not allowed to launch this type of machines as a new account. So if that's the case, just delete the stack. So go back here, go back on the top of the screen, click delete here. You should have a create fail here, a rollback complete. You delete and you go back to GitHub and you launch again, this time selecting MLT2 medium, okay? If you have another error, ask on Slack. Okay, but so here the snake is ready. So the first thing we will do is to test it in a Battlesnake game. So you can see if you go down a little bit, there is one link here, Snake API. Okay, so this is the link, the URL of the entry point of the Snake AI. So copy that link. Okay, copy that link and go to your Battlesnake account. Okay. So you should log into your Battlesnake account, and now you can go to My Battlesnakes. So I increase a bit the size for you to see better, maybe. Okay, you click to My Battlesnakes, and you click Create New Battlesnake. Here you give a name to the snake, so I will call it Ross, and you pass the URL you just copied from your AWS account. Okay, you can fill other options, and you can allow or not other people to play against yourself. So for now, this is a test. I let it like that. So you save. And once it's saved, you should see your snake here. You can click Create Game. In Create Game, you can see I have my snake named Ross. If you click on the plus, you add it to a game. You can add other snakes here if you know names of snake of friends or snake you want to try to beat, or you can add random snakes here. Okay, so for now, just to test, I will just launch a game with a single snake, Ross. Okay, so let's start game. Okay, so Ross is alone. Not too funny, I agree, but just to check it works. Okay, and you can click play here. And you can see it's moving. He is alive, so he tried to survive the most of the time. So there is no enemies here, so that can continue for quite long. Anyway, if your snake goes straight, never change direction and go straight and hit the wall, it's probably not working. If you see your snake moving like that, that means everything's fine. Your URL is correctly connected and the model is running. Okay. Now let's see how we can improve the snake. So if you go back to your AWS console, there is short links we can use again in the output section here. And for now, we'll try to retrain the model. Okay, so you go to the field model training environment and you click on the link here. And that will redirect us inside the SageMaker notebook to train the snake. Okay. So if you clicked on the link, you should see something like that. So make sure you open the right one. You should see here policy training. So it's a Jupyter notebook. So for those who don't know what it is, Jupyter is an open source software that allow you to share code and documentation in the same single document. So it's an executable document, and this is very commonly used in the AI ML space. So to all the cells, so every section, every block is named a cell. All the cells are executable. To execute a cell, you can click run. Here is just documentation. There is no command to execute, so that does nothing. But sometimes you see a code, a block code. So here it's Python, and you can see some Python code. So here we just import the environment inside the current notebook context. So click next. If I click run. So what you can see here is the state of these cells change. When you have a star, that means the cell is currently running. And when you have a number, so it will a number 1, 2, 3, 4, and so on and so on, that means the step is done. So here, this is executed correctly. Okay, so we can continue. Now we will initialize SageMaker from what we imported. Basically, what we do, we initialize the default parameters. So click run, and you should see an output just here, S3 bucket path. So yours will be with a different number here, but this is the bucket, the S3 storage bucket, where your model at the end of the training will be stored. Then we give a name to the training job, and we get a role. So a role is a thing that provide you permissions to do certain action on your AWS account. And here your notebook instance need to launch training. So he will launch some server, so he need to have permission to that. So execute that. You should see a line similar to this one. And then here you have a choice. You can use the local mode or standard, not local mode, I will say. So local mode will means currently this Jupyter notebook is running inside a server called a notebook instance. You can use this server to do the training, okay? But with SageMaker, one of the powerful things is that you can launch other servers, and you can launch a large group of servers if you have a large training to run in a short time frame. And here, so if you change to true, you will train locally. If you let it like that, you will use the instance type you defined before. So here, I will let everything default. I suggest you do the same. Let default and just execute. Okay. Let's go down a bit. So here, we will get the base image that we want to execute containing RL lib. We want to load that inside the training instance. This image is prepackaged, provided by AWS and SageMaker, and contain everything you need to run your model. So click next. Okay. So now you have everything ready to launch a training. You can see these lines will be actually running the training. In fact, this line estimator fit that runs the training. But let's talk a little bit about the parameters we have here. So this is the entry point of the code of the training. Everything is ready for you. Again, some dependencies, image name, role, we defined all of that before. Train instance count. So here we will launch a single server to do the training, but you could have put more. I suggest you to let that. The output job name prefix is to organize your model inside the bucket. And here, the important section that every ML algorithm will have is called hyperparameters. So these are model-specific parameters that every algorithm, like RL here, have. So here we have two parameters suggested you can tune. Number of num iters is the number of iterations that the instance will do. So the higher the number here, the longer it will take. You can let 30. That will take around 20 minutes. For the demo, just showing you how it works, I will put 4, so it will take only very few minutes, like 3 minutes. And here is the number agent. As John explained, Battlesnake is a multi-agent environment. So in order to train, we need to train a snake against other snakes. Okay, so this is the number of snakes we will have in a single game. All these snakes will be the same AI, and all these snakes are learning. Okay, so once you're ready here with your settings, click run. Once you click run here, yeah, you should see something like that, starting the training job, and you will have a lot of logs coming here. These steps will take around like 4 minutes with the number of iteration I put. So during that time, I will switch back to the presentation to let my colleague Hannah explaining how this works.
Sorry, I was muted. Thanks, Xavier. This is Anna. As we just saw from the notebook, we have Kickstart, a SageMaker training job, and it usually takes 2 to 3 minutes to start seeing the logs. And I'm here to explain what's happening under the scene. Essentially, when you use SageMaker mode to kickstart a training job, SageMaker will prepare a dedicated ML instance for you. For example, for this specific job, we chose to use ML T2 instance, and then SageMaker will prepare that instance for you. And the good thing about SageMaker is that you only pay for the time used for the actual training. So once the instance is ready, SageMaker RL started the actual training job in that in that orange box where the RL agent keeps interacting with the Battlesnake environment. The agent sends the action and the environment sends back the observation. Using these observations, what we call experiences, the policy keeps updating itself. As what we have just seen in the hyperparameter setting, we only train the network or the policy 4 times in this demonstration. And after the model being started training, we can get access to the training status through visualization. So we can see this job appearing in the SageMaker training console. And if we click into that training job, we can see the real-time metrics popping out in the CloudWatch metrics part. And through that place, we can check the status of the training. For example, what is the episode length? What is the reward maximum and mean value? With the model being trained already, now you can decide either to directly deploy the model or start tuning your model based on the performance. So now if we go back to the notebook example, let's check the status.
Okay. So here's am I back? I don't think I'm back. I'm waiting, I'm back. Okay, thanks. So here you can see logs are accumulating and the training started. Okay. All these blue logs are logs from the training itself. You can, if you go down a little bit, so probably here the first step over the 4 steps we have been executed. So let's go down a little bit. It's in progress. Okay. So wait that this finish, and during that time, I will go back on the AWS console and on SageMaker interface to show you what Anna just talked about. So let's go over here. Yeah. So from the AWS Management Console, to go to SageMaker, you have to use the navigation bar here, click on Service, and type SageMaker. You have a link, you click on the link, and you are redirected to the SageMaker service. And by the way, this bar is to use for navigating to any AWS services. Also here, you can see an important information is the region we are running into. So we are currently connected to the SageMaker service inside the Oregon region. You can switch region, clicking on that link and selecting another one. But here we run the lab here. So if you look here on the left side, you can see several sections. You can see, so here notebook is where we have notebook instances. So if you click here, you will see we have one, the one I created before. It's in service. This is the instance. So understand the server that is running the Jupyter notebook we are using. If you go down, you can see training. Inside training, there is algorithm and training job. In training job, a training job is an abstraction of a training that can be launched or executed on multiple AWS instance. So click on training job. Okay, and you can see I've got this training job I launched today is currently in progress. And this is where we can find the information that Anna just mentioned. So let's click inside the training job and look what's inside. So we can see that the training job ran for 229 seconds for now. The status is still in progress. If I go down, you can see some information about the algorithm. So it's the image, the exact algorithm version we use. Okay, going down, the instance type, so the type of server that is running, we launch only one. I skip that. Here, again, is the bucket, the S3 bucket, where the results will be stored. So the results of the training is a new model. So we will have a model file inside this bucket at the end of the training. And here are the hyperparameters. So the two we defined explicitly in the notebook was the number of agents, 5, and the number of iterations, 4. These other are hyperparameters are defaults. And if we go down a bit, we can see there is monitoring. So maybe I can refresh. I don't know if I have. No, the job is not running for long enough to generate a metric yet. But if, in general, if you have a training, usually that can take a bit of time. So you can follow here some information regarding how your servers running the training behave, CPU utilization, memory utilization, disk utilization, and so on. And the other thing you have is a link to the logs. So the logs are the exact same logs that you have on inside the notebook, but they are streamed also to Amazon CloudWatch. So if you want to see the logs, you can explore this way. Okay, going down a bit. And another thing we have, another section. And if you remember the architecture of the project, so I'll just go back a little bit here. I just share again the architecture of the project. Remember, we have, so the 3 orange big boxes. So this one is the endpoint. So I show you this one. No, sorry. This one is a training instance we just explored. This one is where the notebook, the Jupyter are running. And this one is where the AI decision is, and the AI snake, the snake playing the games is actually running. And it's named the SageMaker endpoint instance, also named inference instance. So if you go back to SageMaker, you can see under inference, we have endpoints. An inference endpoint is a notebook instance, an instance, a SageMaker instance executing the Snake AI. So this server here, Battlesnake endpoint, is actually the one doing the decision during the move. And what we will do with this, once the model is finished to train, we will go to, we will replace that endpoint by a new version of it containing the new model version. Okay. So just to clarify a bit, here when we use the training, we didn't change. So you can see that the training is over, I think. Yeah, you see there is a number here. The training, if you go down at the end, you should see very end. Okay, it's done, and we finished the last steps. Okay, but here we didn't change any settings of the training. Obviously, you can make change here, and we explained inside the GitHub project what source code to change, and here you can change some hyperparameters. But if you want to change more, you have to edit the code. You can do that inside Jupyter. Everything's explained inside the notebook, the GitHub project itself. For now, we just retrain with the same settings. We just train 4 times. Okay, so now we can continue executing the next cells. You can see this is the output of the training, and it's an S3, it's a model file. So this is the new model we produced with that training. And we want now, with these steps, to deploy that model, to update our inference endpoint, to use that model instead of the previous one. So the previous one you launched at the beginning was a pre-trained model that we packaged. This time, it will be yours. Okay, so here again, run cells. So what we do here, we delete the endpoint. So on SageMaker, that means here you can see under inference endpoint, we deleted the endpoint, so there is nothing. So now your snake is not working. Okay, so we just killed the snake, just to be clear. But now we want to recreate the snake with a new model. So click run here. And these are the instructions to copy the model at the right place and basically launch a new instance with the updated model. Again, if you go back here to SageMaker, after some time, you should see, so here it's creating. This is the new server containing the new model, the inference endpoint, and it's currently in creation. That means it's booting, okay? So while that boot, okay, it can take a few minutes to boot. We can switch to the next session, the next step. So here we'll finish that once this one is finished. So let's go back to CloudFormation here. So CloudFormation stack. Okay. So if you reopen CloudFormation, remember you have in outputs you should have another link, Heuristic Dev Environment. Okay, so this is the step 2 inside the GitHub instruction. And this is the place where we will tweak how we want to, we will tweak the specific behavior that will override sometimes the model decision. So I open this one. Okay, so this is opening. Just for you to be clear, if you want, you can use Jupyter not with these short links. These short links are only here for convenience. You can also go to SageMaker service. You go on notebook instance, click on Jupyter, explore notebooks, and you can go here. This is the same. So I'm just waiting that the notebook is started, and we'll start executing that. And I'm also looking here at the icon for the other notebook. When this icon changes, I will go back to this one to show you the end. So the first step, execute the first column to install some dependencies inside the notebook. So basically, this is doing some Python package installation, and we have to wait that this to be over. And once it's done, as you can see here, we will need to reboot the kernel of the notebook instance. So I'll show you that as soon as this is finished. So I am waiting one of these two operations. Maybe during that time, I can show you just how to go straight to Jupyter going through SageMaker. So if you are in the console, again, to go to SageMaker, you click on Service, and you can type SageMaker, or you can use the history here. So I just click to SageMaker. And I go back to the SageMaker service. So I keep an eye on the two tabs here, two heuristics that are currently running. And here, going back to the notebook instance. So here, click on notebook instance on the left menu. In service, you can see two links. There is Open Jupyter and Open Jupyter Lab. Okay, Jupyter Lab is just a more, it's an overlay of Jupyter. So let's open Jupyter Lab just to show you what it looks like. Okay, so here we open Jupyter Lab at the root of our server, and we can see we have some source code inside Battlesnake. This is all the code that have been deployed by the CloudFormation stack, and the notebooks we need are inside these folders. So everything is in the instruction, but just for you to mention, you can have control over the notebook instance server. If you click here under terminal, you will have a standard Linux terminal, and you can administer the notebook server this way. So if you want to type like things like git commands, you can go here. So under SageMaker, Battlesnake, this is where all the code is. Okay. Here, if you want to do some git to put that your code under configuration, your changes, you should go here and type your command here. So this is explained again in the instruction of the open source project. So here I saw that this execution is over. So that means all the packages have been installed. So probably if you did the same at the same time than me, your package are also installed. So remember here, we need to restart the kernel. To restart the kernel, you have two options. You can click on this small arrow here, or you can click on the kernel, restart. So do that. You say yes, restart. Okay, that's ready. So that was fast. And now we can continue. We have our dependency installed. We can continue executing the rest of the notebook. So some library import. And now let's define an OpenAI gym. So with the gym environments that we created, we added a feature, I would say, to what the Battlesnake engine can do. We added an option to enter an initial state of game inside the gym environment that simulates the Battlesnake engine. So this way, if you want to to see how your snake behave in a very specific situation to make sure that he does what you hope he will do, you can load a specific state. So this is the exact API of the move API of the snake, of the Battlesnake. So here, if you want to overload the state and if you want to put a specific situation, you can put true and update to the situation you like. So you put the number of snake you want, you put more food, you can have longer snakes, you put everything. Okay. So I will let default run that cell, but you can do that. And here, initialization of the gym environment. So click run. Okay. So now we will load the train model. So the model have been already trained in the previous notebook we did. And we can continue. So just before that, I see that the other notebook finished here. So I just come back here and you can see we can test the endpoint. If you like, you can do that. So here, test the endpoint. So I went back to the policy training just to launch a snake. You can see it worked. Also, if we go back to SageMaker and we go to training job, we will probably see here that the training job is complete. Yeah, here, complete. And if we go to endpoint, we will see that now the endpoint is in service. So you are again able to run new games. The URL didn't change, so it works. Okay, now let's continuing the Heuristic Developer notebook. So here I'm switching to Heuristic Developer, okay? And I'm continuing into this cell. First, we will download the model and deploy the model locally. So let's run that cell. Okay, my model is now ready. Okay, another import. And so I wait till it's done. So wait until this is finished. Okay, see, it's executing. Let's wait a bit. Okay, it's done. You see, there is a number. Let's go down. So now we will run the simulation loops. That means we will execute the gym environment, and we will start from the state you define as a first state, or the one by default if you left false, and then we will load the simulator. Okay. So here, yeah, just important to have in mind. So it will be loaded this Python file, okay? So localhost rlib inference src Battlesnake heuristics. This is Python source code which contains the heuristics themselves. So if you want to tweak the behavior of the snake, this is the file you have to edit, and then you go back here and you launch simulation and you restart simulation again and again and again. Okay, so just look, it's inside this localhost rlib inference src Battlesnake heuristics. So if you opened the Jupyter Lab, for example, you can see it's under localhost this one src. No, what was the file? Did I remember? rlib inference src. rlib inference src, and you can see I can increase Battlesnake heuristics. So if you want, you can edit directly the source code, the Python source code from here. And you can see here we created, for the purpose of demonstration, we created a heuristics. So this is a very simple heuristics that decide to go eat food. If you have a food close to your head, then we will push the snake to eat food. Okay, this is an example. I don't know if it's a good idea, but this is why we put. Now you can implement new strategies, like avoid colliding your own body, eating another snake, and anything as complex as you need. And you have to implement that here. And you then the run steps execute all the heuristics. So basically, go here and update your code. So that will take a little, quite a lot of time to define your strategy. This is where you will work the most. So here I will let everything default. We will just try this heuristics of eating food that is close to my head. Going back here. So let's suppose you're happy with your changes, and now you can execute, load the snakes, and so everything ran, and now we want to see what happened. So let's play back the simulation. So run that, and you should see something like that. So as you can see, it's a visualization of the gym environment state, which is very similar to a Battlesnake game. So here, all these squares are snakes, and the red one is food. Okay, you can see we have our snakes here and with their health. You can do a step-by-step to see what happened. So all the snakes are following the same AI and heuristics, and you can see step-by-step what happened. So they are moving, you can see. Yeah, some of them are died, you see. It's exactly like the Battlesnake game. It's just step-by-step with all the, and you can do also a reverse, you can go back. So if you want to understand exactly, oh, it was this situation, oh, I messed something in my code and so on. And you can also click play, and it will play all the steps that happened during the game simulated. Okay. Okay, so tweak your heuristics, change your snake behavior, then go here, launch the simulator, see if you are happy in a specific situation, and iterate to do better. And once you're ready, you can continue for the next steps. The next steps basically will be now to deploy that and update again the endpoint we are using in our real games. So let's go down a little bit. Again, execute the next cell. So this is, or you can also, yeah, it's a way for you to see, if you want to, for a specific step, if you want to see the extract the state, you can extract it here. So you can see here I'm on step 11 of the game. So here is a turn 11, and this is all the information. It's a way for you to save that and load that somewhere also on. Okay, now we can deploy the SageMaker endpoint. So we will deploy again our endpoint with this new heuristics. So click next, load information. Yeah, we are good. And now deploy new heuristics. So again, here the principle is the same as the previous notebook. We start deleting the endpoint. So here I deleted the inference endpoint. So again, my snake in my game is dead. So do that not during a game, do that when you are in development phase. And we will create a new one. So you can see, again, to be clear, the endpoint, if I refresh, there is no endpoint because I just deleted. Go back here. I can recreate one from the model and the heuristic we just deployed. So let's do run. Okay. And again, the model deployments takes few minutes. So in something like, I don't know, 10 minutes, 5 minutes, 10 minutes, we'll have again a snake ready to use. Okay, and again a test. So this is the end of the notebook. So very similar to the other one. If I go back again to the general architecture, we started doing the SageMaker model training with the first notebook where we trained and redeployed the snake with a new AI model. And then we did the second step, modifying the Heuristic Developer notebook. So here I didn't change anything, but you should. and running the simulation. And once happy, deploy again the SageMaker endpoint instance. So in order to use this package during the real competition, what you have to do is working on heuristics and maybe improving training, maybe training for a longer time, something like that. And you will have better snakes than the default one provided here. So I hope all of that will be helpful. I just check if there is question from Twitch. Again, if you need help, remember. Okay, just checking if there is questions. Okay, again, if you need help, remember there is a URL for this workshop. So the workshop will be over soon in terms of live stream, but you can continue running it and go on the Slack channel. Remember, all the information is under our wiki, this page here. So the main URL to use is this one, TinyURL Battlesnake -AWS. And you can see that you can find help on the Battlesnake Slack under channel Snake Dev Machine Learning. One last thing to mention before finishing this lab is when you are done with your workshop, if you want to, especially if you launched using MLT2 Medium, the instances are currently running on your account. Okay, you have instance launch on SageMaker, and you will occur charge for that after some time. So if you are done with the workshop, or if you want to put that in pause before continuing your working on it, you should either stop the instance from here, or if you are totally over with the project for sometimes, if you let's say you save your changes under Git, you should go back to CloudFormation service. So you go back to CloudFormation, and you should delete the stack. So that will clean up. So if you click here and you click delete, so you will see that will destroy all the information, including the running server, and you should not occur any charge for anymore after that. So don't let all your server running forever, otherwise you will receive a bill for something you're not using at the end of the month. So don't forget, do that if you need. If you want to put your project on pause, it's explained inside the project how to do that. And again, you can come on Slack to ask us questions. So that's it for this workshop. Oh, okay. What's the question? Okay. Okay. So to open Jupyter Lab, you go on service and you type SageMaker. You need to be on the SageMaker service. Okay. So click on SageMaker. Okay. So here, left menu, the Jupyter Labs have to be opened from the notebook instance menu. So click on the left menu under notebook instance. You can also click here, that's the same. But let's click on the left menu under notebook instances. Click here, and you will see the list of notebook instance you have. So if you follow the workshop, you should have one. Okay. And here you can see, don't click, here you can see on the right, there is two links, Open Jupyter and Open Jupyter Lab. So these, you can use Jupyter or Jupyter Lab that have a little bit more features to edit directly the source code, okay? If you click under Jupyter Lab, you will end up into a page like that. And you will end up at the root of the project, but there you can explore. Yeah, you should end up to something like that with that closed. And the source code is under Battlesnake and everything is here. Okay, and the code you have to tweak for your snake is under localhost. Okay. Again, you can open a terminal. I really recommend doing that, especially if you do a lot of change. Save your code on Git. The other benefit of doing that is if you save your code under Git, from here, once the code is saved, you can destroy the whole environment using CloudFormation. And this way you stop occurring charge, and you can spin up again the environment, I don't know, tomorrow if you want to continue on it. Okay, there is other quickest way to put some servers on pause to stop occurring charge without destroying the environment. We can discuss that on Slack. Okay, it looks like we have no other questions. Okay, so with that, I hand over to Noah. Thank you for everyone following this workshop.
Thanks, Xavier, and the AWS team for running that workshop again for the second time. Thanks, everybody. Have a wonderful day, and see you next time on Battlesnake Official.